All right. Okay, all righty. Here we go. Actually, now that I think about it, I do for this test allow you to use a note card. And the reason why is because how we graph tangent and cotangent. There's a table that you want to kind of construct. And so what we can do is you can use that note card to help you with this table. So here's what we're graphing. We are graphing tangent and cotangent. Let me kind of give you an idea of what you have in store for you. Tangent looks something like that. It doesn't even look like a sine or a cosine. Okay? So our rules change a little bit in terms of how we graph them. Now cotangent looks exactly the same. Let me label this tangent. Cotangent looks exactly the same, except it does that. So what is the difference between the two? Tangent goes through the origin, and notice that cotangent doesn't. They're shaped exactly the same, just like sine and cosine are exactly the same, just one goes through the origin and one doesn't. Now, you need to understand that cotangent can go through the origin if we have a phase shift, right? Just like cosine could go through the origin if we have a phase shift, okay? So that's what we're going to show you. We're going to show you how to graph these two functions today, okay? The most difficult that they get is with the vertical shift. The vertical shifts are very easy with these, okay? So what we want to do is we're going to construct a table here. I'm going to have tangent over here, and I'm going to have cotangent over here, okay? And we'll give you the properties of them. You do need to realize that the formulas are the same as before. All the rules apply exactly like they did before. If B is attached to X, you're going to have to factor it out, but all the letters mean exactly the same. So that's good news. Okay? Here we go. So let's talk about amplitude, period, vertical shift, phase shift. We do have to add a new little formula, and that is how to calculate the asymptotes, your vertical guides. So we're going to have to show you how to do that. That's the only thing that's different, really, between these. Okay? Well, just look at this graph here. What would you say the amplitude of tangent is? 0. You can't measure how tall this goes. So your amplitude is none. So when you really think of it in the grand scheme of things, the only trig functions that have an amplitude are sine and cosine. All the other four don't. Cosecant, secant, tangent, cotangent do not have amplitudes. So if you make a note of that on your little note card, that the only thing that has an amplitude is sine and cosine. That's it. Everything else is none. All right, the period. Okay, for all the other trig functions, it was 2 pi over b. And do I need to, so here, it's not 2 pi, it's pi over b. Okay, common mistake. We're so used to always doing 2 pi divided by b. But notice that tangent and cotangent are kind of like half the distance. They're not quite as wide. If I were to graph sine and cosine, they would go here to here. Okay, and so notice that they pretty much just cover half what sine and cosine do. So that's why the period is cut in half. Okay? Vertical shift is C, as always. Phase shift is D, as always. Now, I said I'm not going to have you graph a phase shift, but let's say that I threw it as extra credit and you wanted to try an extra credit. If you do have a phase shift, what do you think you're going to set this up to? 0 is less than or equal to whatever, less than or equal to what you think? It's just going to be pi. Sine and cosine for one period is 0 to 2 pi, but for tangent and cotangent, if you were to do a phase shift, you would just set it to pi, not 2 pi. Okay? All right. Last thing, to graph these trig functions, to graph tangent, you have to know these. And there's a simple little formula that just tells you that tangent stays between these. okay? And there's a formula to calculate these out, okay? So these are called your vertical asymptotes. Here's how I do it. I do it a little differently than the book. I just do it this way. The formula to calculate these is b times x equals plus minus pi over 2. B times x equals plus minus pi over 2. So you're going to have a negative answer and a positive answer. They'll always be the same. If this is 2 pi, then that's negative 2 pi. If this is negative pi, that's positive pi. Okay? Last thing, direction is always nice to put, so you got an idea of what it looks like. If you are graphing a positive tangent, in other words, your A value is positive, then that tangent wave goes left to right, like so. Okay, that tangent wave will increase as it gets bigger. Okay? If you're graphing a negative tangent, in other words, A is negative, that tangent wave is reflected. Okay? So now notice that it's getting smaller as it moves to the left. It's going towards the negative numbers. Okay? So it's a good idea to understand what the graph is going to look like. Positive tangent, left to right. Negative, right to left. Any questions off that? Okay? Let's do cotangent, and then we'll just graph a couple. So amplitude is going to be the same, none. The period is still pi over b. Vertical shift is still the same. Phase shift, still the same. It's your d value. Okay, so everything so far is hunky-dory. Everything's identical. The formula to calculate the asymptotes is a little bit different. Here it is. It's two separate ones. B times x equals 0, because we're not going through the origin, so you set it equal to 0, or b times x equals pi. Okay? So for tangent, it's plus minus pi over 2. For cotangent, it's 0 and pi. Two separate formulas. Okay? So real quick, here's what they look like. A positive cotangent looks something like this. Notice it's not going through the origin. Notice that a positive cotangent looks like a positive tangent. Do you notice that a negative cotangent and a positive tangent? Oh, wait a minute. I'm sorry. A positive cotangent looks like a negative tangent. So notice how they're kind of opposite. You know, the opposites are the same. So then the other way, a negative cotangent just does the opposite. It looks like a positive tangent. But notice it doesn't go through the origin. There you go. I would definitely write this on your note card that you get to use on your test on Wednesday. And I'll give you note cards tomorrow. Any questions? We're just graphing these in simple form today. So you'll easily get this done, and that hopefully gives you a little chance to focus on those phase shifts and get those done. Okay? All right, let's just do a couple real fast. I think that's all you need to see. Here we go. I'll leave that chart right there. Let's graph this one. Y equals 2 tangent of x. Like I said, pretty basic today. Again, when you're listing your C and D values, if you don't have them, you could say 0. You could just say 0. You could say none. Okay, whatever works for you. So now when you're graphing tangent and cotangent, we know that we have to add another step. And I just usually put ASY, for your asymptotes. Okay, and you don't have to do this on sine and cosine. Only on tangent and cotangent do you need to add this extra one. If this was a sine wave, you would stop there. Okay? All right, what's our amplitude? 0 or none. Okay, our period is pi divided by 1, so it's pi. Our vertical shift is none, and our phase shift is none. Okay, we do have to calculate our vertical asymptotes, So notice the formula is b times x equals plus minus pi over 2. So it's going to be 1 times x equals plus minus pi over 2. Well, we like it when our b value is 1 because we know our vertical asymptotes. It's x equals plus minus pi over 2. When we do our other example, I'll make sure to give you a different b value so you can see how it works. We're ready to graph. Here we go. So we know that it takes 4 tick marks to graph a trig function, right? So this is pi over 2. I should have waited. Let me do this. So if I draw my x-axis, I know that this is negative pi over 2, my outside vertical asymptote. 1, 2, 3, 4, and this is pi over 2. So those vertical guides, those vertical asymptotes tell you what your outside numbers are. Negative pi over 2 to pi over 2. Do we know where the y-axis is at this time? Right smack down the middle. Okay, these are your vertical guides. I'll always draw dashed lines through them. Okay, how can I calculate this? Now you do know that this is 0. So what is this point to that? Isn't it half the distance? If this is 0 and that's pi over 2 and that's in the middle, can't I just say, oh, what's 1/2 times pi over 2? Pi over 4. So this is negative pi over 4. So to calculate the intervals of tangent and cotangent, we can go back to what we did in before phase shifts. If this is 0, this is 1/2 of that. We're done. We're ready to graph this thing. Pretty darn easy. Here's the only thing the a value tells you. We know that we're graphing a positive tangent and it's going to go this direction. So what this a value tells you is that this interval here at negative pi over 4, we are 2 below. And then at pi over 4, we're 2 above. So we know it goes through the origin, so we know that. So this a value tells you not this point, because it'll never touch these. Okay? So at our first interval, which is negative pi over 4, we're 2 below. And then at our third interval, we're 2 above. So this tangent wave rides along the axes here, comes up through these 3 points, and then rides up like that. That's how tangent works. So really, you're only graphing 2 points. You're graphing 2 below negative pi over 4 and 2 above. Okay? Watch this. If I just did a vertical shift of tangent and cotangent, most people, and I'm going to say most people like to do it the old way. They'll graph tangent just like I just did, and they'll just say, hey, that bumps up 1, that bumps up 1, and that bumps up 1. For some reason, when we do vertical shifts, people like to do it the both methods. They like to do the original graph, and it's just so easy to bump every point up 1. But if you're like, nope, I'm going to do this and just draw a new x-axis, you're more than welcome to. I don't care which way you do it. Any questions? That's a tangent wave. So it's just whatever this is, b times x equals plus minus pi over 2. That tells you your outside guides. If this is your first one, 1, 2, 3, 4, you know the middle will always be the origin, right? Okay, let's finish up with a tangent and we're done. And this is as hard as they get to what I just did. The only thing I guess that'll make it harder is I'll put something there to make it a little different. Okay, all right, here's our last one. How about y equals, maybe I got one, let me look. Nope. Let's go y equals negative 2, or let's go 3 cotangent of 1, or let's go pi over 2. Let's do a fraction. Okay, let's graph this thing. So, what's our a value? Negative 3. What's our b value? 1/2. Okay, our b value is 1/2. Oh, I'm sorry. Woo. Make that x over 2, not pi. Sorry. But do you agree that x over 2 is 1/2 x? Okay, x over 2 is 1/2 x. Okay, there's a 1 in front of that x. Okay, so our b value is 1/2, c is 0, d is 0. The hardest you'll see is a vertical shift. Maybe I'll give you a c value. Okay, all right, quickly label these. Amplitude is none. Period is pi divided by 1/2. What is that? What's pi divided by 1/2? Is what? X time, or pi times 2 over 1, which is 2 pi. Kyle, what happens if you miss the period?
You miss 5.
Very good.
Or 10 now?
No, you still only miss 5. Okay? Now, can you do this on a calculator if you needed to? Absolutely. If this is really hard for you, then just go 1 divided by 1 divided by 2 on our calculators. It's going to spit out 2 for you. You just got to put pi back into the formula. Okay? Vertical shift is none. Phase shift is none. Okay, to calculate the asymptotes for cotangent, it's b times x equals 0. So it's going to be 1/2 times x equals 0 and 1/2 x equals pi. You got to set up 2 separate formulas, one for each. It says it right there. Now we just solve for x like we normally would do. I would times both by 2, x equals 0, which that makes sense. We know that cotangent doesn't go through the origin, it's going to stop. Here, if I times by 2, I get 2 pi, and we're ready to graph. We know our outside intervals, we just have to calculate the first 2. I'm going to have to erase this so I can graph it. You should have that by now. All right, here we go. If I know that this is 0 and it takes 1, 2, 3, 4 tick marks, and that's 2 pi, I know that this has got to be my y-axis. Is this easy to calculate your intervals now? Can we go back to what we did before? 1/4, 1/2, 3/4? Yes. We don't have a phase shift, so it's 1/4 of 2 pi, pi over 2, 1/2 of 2 pi, pi, 3/4 of 2 pi, 3 pi over 2. Here's your first dashed line. Here's your second dashed line. We know that it goes through the midpoint, always. Now look at this. Look at what we're doing. We're graphing a negative cotangent. A negative cotangent goes left to right. Left to right. So at pi over 2, I'm going to be 3 down. And then it's going to go to pi, the midpoint. And then at 3 pi over 2, it's 3 above. So do you see that a negative cotangent looks like a positive tangent? It's the same shape. The only thing different is not going through the origin. Okay. What?
I'm so lost.
Why can't you see anything? What are you lost on? What?
Okay, no, I figured it out.
You did not.
I think I figured it out.
Okay. Just follow your chart. Follow the chart. I think these 2 things are super helpful. They at least give you an idea of what the graphs look like, and you can follow that. Okay. No phase shifts, so that's going to make it way easier. To calculate your intervals, if this is 0, you know it's 1/4, 1/2, 3/4, just like we did the very first day with trig functions. Okay. Tangent graphs will always go through the origin perfectly right through the middle. Okay. Make sense? I don't know. I hope so. This is it. The chapter's done. Tomorrow we'll review. Test Wednesday. Okay. Hey, but we have time, so if you're having troubles, I can definitely come around and help you with this and get you going. Okay? I can even help you get one going if we need to do one together, if you need to see one. There's not a lot to do. Wow. you lost on?
I figured it out. I thought I figured it out, but I didn't. I definitely drew it
Okay,
out.
166. I think I was hoping to do like 6 of these, like 3 tangents and 3 cotangents. So let me look. We're going to do 7, 9, 10, 12. Let me write that down. 7, 9, 10, 12. These are like as easy as they get. There's no vertical shifts, nothing like that. But I do want you to be able to do a vertical shift. So I'm going to do 23 and 26. There you go. So naturally finish these up, then concentrate on your vertical shifts, phase shifts from Thursday. I can help you with 7 just to get it going.
So, how do you make it better? That's how you do it. You're telling me right now you understand.
Yeah.
Yeah, why?
So I'm wearing slides. Your aspirates are here, okay?
Yeah.
So plus
Well, I
minus.
did that one.
Yeah.
Okay.
Okay.
It's just, you draw the line through, and that's where it's gonna act. Either like here, Dan's gonna start there, right? All one of them, and it's gonna start and then
There's 7. Pay attention, we'll help you. I'll explain it again.
I get everything up until the aspirates.
Okay. So here's number 7. We're going to graph tangent. I know I erased some of it, but that's all right. We'll set it up as we're going.
Oh my goodness.
So where I get to pick on you a little bit. What's our A value here?
1,
B.
0.
No, A
Oh,
is
we
1.
had A.
B,
For A. 4.
C,
0.
D.
0.
Okay. So that's our first step. Even though it's not graded, you should get in the habit of doing that. Our amplitude is 0, none, right? For some reason I like to put nuns on those. Our period is pi divided by b. Pi divided by 4, which that's the period, pi over 4. Vertical shift, none. Phase shift, none. Okay, let's talk about the asymptotes. These are the formulas to calculate it. For tangent, it's b times x equals plus minus pi over 2. Okay, that's the formula every single time. I know I erased it, but it's always b times x equals plus minus pi over 2. Okay, our b value is 4. So I'm going to go 4x equals plus minus pi over 2. I have to divide both sides by 4. So here's those nasty fractions again. What is pi over 2 divided by 4? Pi over 8. Okay, let's write it out. Pi over 2 divided by 4 is pi over 2 times 1/4, which is 1 pi over 8. Again, if you're having trouble with this on a calculator, just go 1/2 divided by 4. Just do it on a calculator. You got to be careful because I found out on Thursday with my other classes that some calculators you have to put the fractions in parentheses and some you don't. I guess I would be 100% safe and I would just say, what's 1 divided by 2 divided by 4? Like I would always put my fractions in parentheses, like my numerator, denominator, and then I know it'll always be right. Okay? So our answer here is what? Plus minus pi over 8? Okay, we're ready to graph it. Now all this tells you is your first point is negative pi over 8. 1, 2, 3, 4, and this is pi over 8. The asymptotes tell you your outside guides, your outside values. So negative pi over 8 to pi over 8, which tells you that 0 is right smack in the middle, which that's what we would expect with tangent, to go right through the origin. Okay? I like to draw these dashed lines. It just tells me that this graph will never go past it. It gets closer and closer, but never through it. It just keeps getting closer. Now, how can I calculate this? What's this compared to that? This is what in terms of distance? It's half the distance, right? This is just 1/2 of that. Well, what's 1/2 times pi over 8? Pi over 16. And then this is negative pi over 16. Okay, we're ready to graph. You're graphing a positive tangent. If you look on your chart that I drew, positive tangents go left to right like that, right through the origin. So I know it's going here. The only thing that this A value is used for is to tell you where does it go through at this interval and that interval. It never goes through this, and it never goes through that. So since I know it's going left to right, at -1, it's its lowest, then it goes through 0, 0, and then at +1, it goes through that. That's it. So it just rides along this asymptote, comes up through those 3 points, and then curves up like that. If I made this a negative tangent, the only thing different, it would have went this way. At -1 this way, and up through like that if it was negative. That's the only difference between the two. Still goes through the origin perfectly, right? If I added a vertical shift of 1, you just bump up every point 1 unit. Just draw it. Okay? That help a little bit? Try the next one. The next one's a tangent 2. So like 7 and 9 are tangents, 10 and 12 are cotangents, and then 23 and 26 are still tangent and cotangents, but I added a vertical shift. Okay? But we got a lot of time. Hopefully you get maybe this part done. If you think, hey, I got this, I just need a little help with phase shifts, then do a phase shift problem and I can come around and check it out. Okay, but no matter what, we're reviewing tomorrow. I will collect everything tomorrow. This assignment, Friday or Thursday's assignment, this assignment, everything will be due, and then I'll have some problems for you to look at for your review. What? Nurse? Got a sore throat? Okay. If I like to do this real hard, will it help? Oh, yeah. May go.
How did you feel if I flicked your
Hmm? I'm fine. Because that's what your A value is. So if A was 2, then it would go through at pi over 16 at 2, and then at +2. Yeah. So the A value tells you, so that's why it's 1 below and 1 above.
And then, so you'll be doing that. Why? All the time.
There's this one.
Okay, because what you did
There's a bench.
is, I know, and that's fine because you wrote which.
It's like
That's fine. So, yes, you can do that. Yes. I just found that people make less mistakes if they always put 0 to 2 pi, because then it's the same every time. And then when they divide by 2, then you
Run out.
So either way it works. I've had people do it both ways.
I was saying last weekend, remember, we almost got a buck. We were so close to the 3 by 3. And I walked down, broke some plantation.